Okay, so now let's do one example based on what we learned. Basically, we learned two theorems in the previous video, and that is basically for any square matrix A. To be more exact, theorem number 1, we said that basically we had these two theorems. Theorem 1. In theorem 1, we said that for any square matrix A, matrix A with real entries, with real number entries, A plus A prime is a symmetric matrix, and A minus A prime is a skew symmetric matrix. And we proved that, right? Theorem number 2, we said that any square matrix can be expressed as the sum of a symmetric and a skew symmetric matrix. Okay, and we proved both of these before. Now let's do an example here. Example number 22. Example number 22 is we want to express the matrix B, as basically 2, -2, -4, and -1, 3, 4, and 1, -2, -3 as the sum of a symmetric and a skew symmetric matrix. As the sum of a symmetric and a skew symmetric matrix. Now, in order to do that, so basically in the second theorem we said that basically, for example, if you have some matrix A, you can write it as 1/2 A plus A prime plus 1/2 of A minus A prime, and that would be equal to A, of course. And then we proved that basically this is a symmetric matrix, and this would be a this over here would be a skew symmetric matrix, right? So we'll do the same thing over here, meaning that I can calculate 1/2 of A plus A prime for B, for example, meaning that I will calculate 1/2 of B plus B prime. So B prime, or the transpose of B, is just basically 2, for example, 2, -2, -4, -1, 3, and 4, and 1, negative 2, negative 3. That is the transpose of B. Now, if I calculate 1/2 of A, 1/2 of B plus B prime, if I calculate 1/2 of B plus B prime, what I will get is basically 1/2 of, now I have to add the corresponding elements of this matrix and this matrix together. So 2 plus 2 is equal to 4. Negative 2, negative 1 is negative 3. Negative 4 plus 1 is equal to negative 3. Negative 1, negative 2 is equal to negative 3. 3 plus 3 is equal to 6. 4 minus 2 is equal to 2. 1 plus negative 4 is equal to negative 3. Negative 2 plus 4 is equal to 4 minus 2 is equal to 2, and negative 3 is equal to negative 6. So that is basically the matrix 1/2 of B plus B prime. Now this is supposed to be a symmetric matrix. A symmetric matrix means that if you have some matrix A, for example, then A prime is equal to A. If that's the case, then you can say that the matrix is symmetric. So now if I calculate 1/2 of B plus B prime and take the transpose of that, I will get basically 4, negative 3, negative 3, negative 3, 6 and 2, and negative 3, 2 and negative 6. Right, so that is the matrix that I have. And actually I should do something over here before I do that, which I forgot. So I have to multiply this 1/2 by this matrix. So I have 1/2 times 4 is equal to 2, negative 3 halves, negative 3 halves, negative 3 halves, 6 halves is equal to 3, 2 halves is equal to 1, negative 3 halves, 2 halves is equal to 1, and negative 6 halves is equal to negative 3. Now, this matrix is 1/2 of B plus B prime, and it's supposed to be a symmetric matrix. So that means that if I take the transpose of this, which is 1/2 of B plus B prime, and take the transpose of the whole thing, that will give me basically 2, negative 3 halves, negative 3 halves. I'm just taking all of the rows, for example, and making columns from them. Negative 3 halves, 3, 1, negative 3 halves, 1, and negative 3. Right, so that is basically one thing. And if I compare them, what I will see is that I have the exact same matrix here, and you can say that basically 1/2 of B plus B prime whole prime is equal to 1/2 of B plus B prime, and therefore basically 1/2 of B plus B prime, 1/2 of B plus B prime is a symmetric matrix. Is a symmetric matrix. Now, the skew symmetric matrix must be also created. So I have these two matrices here. Now I take a screenshot here, and I hope that you will do the same as well, because I cannot show this. It seems that I can't even do that, which means that I'm going to, let me see. Okay. So now I need to move this to my other monitor. You will not see it anymore. And so I will have to work down here. But I can actually write down the matrices one more time here. So B was basically this matrix here is 2, -2, -4, and that's -1, 3, and 4, and that's 1, -2, -3. That was basically B, and B prime was basically this matrix as 2, -1, 1, -2, 3, -2, and -4, 4, -3. And then you have, now I want to find the skew symmetric matrix that we need. So the skew symmetric matrix, I can write it as 1/2 of B minus B prime, if I'm not mistaken. Now you can basically say that, for example, let some matrix Q, for example, let Q be equal to 1/2 of basically 1/2 of B minus B prime, which is equal to 1/2 of B minus B prime would be 2, for example, -2 is equal to 0, -2 plus 1 is equal to -1, -4 minus 1 is equal to -5, -1 plus 2 is equal to 2 minus 1 is equal to 1, 3 minus 3 is equal to 0, 4 plus 2 is equal to 6, 1 plus 4 is equal to 5, -2 minus 4 is equal to -6, and -3 plus 3 is equal to 0. And if I multiply 1/2 by this, I will get 0, -1/2, -5/2, 1/2, 0, 6/2 is equal to 3, 5/2, -3, and 0. And now if I take the transpose of this matrix, meaning that if I write Q prime, that's going to be equal to basically taking the rows and making columns out of them. So I have 0, -1/2, -5/2, 1/2, 0, and 3, 5/2, -3, and 0. And as you can see, this is the same thing as basically if you compare this matrix which is Q and this matrix which is Q prime, so you have -1/2, 1/2, -5/2, 5/2, basically 1/2, -1/2, 3, -3, 5/2, -5/2, -3, +3. So this is equal to -Q, which means that Q is a skew symmetric matrix. Q is a skew symmetric matrix. Right? So that is that. So now we have, if I call basically this matrix, if I call this matrix P, so P is a symmetric matrix, Q is a skew symmetric matrix. Now, I need to basically, I can make a screenshot here. And now if I, basically the matrix that I started with, was the matrix B, which was basically this matrix which was basically this matrix over here. And now I have another matrix P, which is a symmetric matrix. I have another matrix Q, which is a skew symmetric matrix. If I add P and Q together, I should get B, right? So P is basically this matrix over here, which is basically so if I now write P plus Q, I will have P we found it to be 2, negative 3 halves, negative 3 halves, negative 3 halves, 3 and 1, and negative 3 halves, and 1 and negative 3. And Q was basically this matrix here as this matrix exactly. So the 0, negative 1 half, negative 5 halves, 1 half, 0, 3, 5 halves, negative 3, and 0. If I add these two together, that gives me basically 2 plus 0 is equal to 2, negative 3 halves, negative 1 half is negative 4 halves, which is negative 2, negative 3 halves, negative 5 halves, negative 8 halves, which is negative 4, and negative 3 halves plus 1 half is negative 2 halves, which is negative 1. 3 plus 0 is equal to 3, 1 plus 3 is equal to 4, negative 3 halves plus 5 halves is equal to 2 halves, which is equal to 1. 1 plus negative 3 is negative 2, and that's a negative 3, and that is my matrix. Now, I think this is equal to actually B. Now, this is 2, negative 2, negative 4. I'm comparing it to B on my other monitor. So, negative 1, 3, 4, 1, negative 2, negative 3. This is actually equal to B. So that means that basically B is equal to P plus Q, where P is a symmetric and Q is a skew symmetric matrix. And that way we have expressed the matrix B as the sum of a symmetric and a skew symmetric matrix, right? Now the next thing that we have here is exercise 3.3. It's not much. A couple of exercises. We will go through them in the next video. I'll see you in the next video, and thank you.